A very good morning, guys. Today we are going to see about the subject manufacturing process 2. Okay, the name itself speaks about the different processes that are carried out in the mechanical industries over the material to get the final product. So, before starting with the different processes, first we will have to understand the basic concept of the machinability, or how or what are the factors, okay, different factors that are responsible and that are necessary to take into consideration while doing the different processes over a material to achieve the final product. Okay, so we will start with the concept that is nothing but the machinability. This is a combination of two words, that is a machine and ability, right? So what does that machinability means? Machinability is the ease with which a given material may be worked with a cutting tool. Okay, how easily you can perform the operations on a material, how with what ease or with what comfort you can carry out the operations with a cutting tool over a material to achieve the final product is nothing but the machinability. Okay, so the machinability of a material is usually defined in terms of it's usually defined in terms of the four factors. Then there are the four different factors on which the machinability of that particular material is dependent on. Those four factors that we have to take into considerations are nothing but the surface finish, how the surface finish of that particular material is all about. Are there any irregularities? Are there any intricate shapes? Is there any too much of roughness over the material? Are we going to need the lot of efforts to carry out the or to shape out the final product from that particular material? So that it is said that the whatever it depends on, first thing is its surface finish. Second thing is regarding the tool life. Tool life is nothing but the how much the life expectancy of a tool is all about. How long the tool can work along with that by carrying out the different operations of the material. Third thing is regarding the force and the power. Force and power, how much force or how much power we are going to need to carry out the operation. The final one, the fourth thing, is all about the level of difficulty in chip control, chip formation, the wastage material formation, or the remains out remaining parts of the chips, okay, that is form out when we carry out the certain operations over a material. Thus, a good machinability indicates a good surface finish and a surface integrity, a long tool life, low force and power requirements, and desired chip control in cutting zone. Right? When we say about it is having a good machinability property, we indirectly say that the material has a good surface finish. It has it can give a tool life as a long period, or a long tool life is achievable by working on that particular material. Force and power, of course, the requirement of these two factors, it is less, or it can be said that it is required in the low quantity. And of course, the desired chip control in the cutting zone, desired level of the chip control in the cutting zone, these are the four factors when we say that any material having a good machinability capacity or the capability does have. Okay, so next part is regarding the machinability index, or we can say the machinability rating, right? Because of the complex nature of a cutting operations, it is difficult to establish the relationships that quantitatively define the machinability of a particular material, right? Sometimes due to the difficulties in explaining or difficulties in establishing a relationships in a quantitative manner, due to the different cutting operations, due to the different conditions, the machinability of a particular material, we find it we find it difficult to establish that relationship, or we can say the analytical relationship. So for that purpose, the machinability rating of a material attempts to quantify the machinability of various materials. We will see this concept. For instance, let us consider the example or relation on the screen, which is given as Km is equals to V60 divided by V60R. Now what does this V60R do means? It can be simply explained as where sorry, V60 is the cutting speed of the target, right? Whatever the cutting speed for the target material is denoted by V60. And what does that 60 means over there? It means that it ensures that the tool life of 60 minutes is there. Now what does that V60R means? R tends to, or it denotes to, reference material. So the reference materials are selected for each group of materials. Either they may having metallic or the non-metallic, ferrous and the non-ferrous. Okay, so among the most popular and the widely used brands. If we say that the machinability index is greater than 1, then the machinability of the target material is better. Okay, so we can say just by looking at over the machinability rating or machinability index, if it founds to be greater than 1, then we can say that the given material is having the good machinability or its machinability is better. And this is what we say with respect to the reference material. Okay, so if at all reference material or the material which with which they belong to a family of, right? So note, we have to take a note that this system can be misleading sometimes, okay, because the index is different for different machining process. This machinability index is different for the different machining process, whether we are doing the different machining operations, like we will see in the further lectures, the operations like turning, okay. Then there are different operations like various operations, milling, drilling, okay. So this might happen that it might mislead the index, because the different machining process, they do quantify the different machinability index. Now for instance, the reference material for the steels belonging to a standard AISI 1112 steel, it does have an index of machining of the steel at cutting speed 0.5 meter per second. Okay, now the cutting speed of that particular material is given as to be 0.5 meter per second, which gives the tool life of 60 minutes. Then how is it expressed as V60R? Since R reference material, since why we have used this R, it is belonging to a family of the steel having a standard AISI 1112. Now V60 is equal to 0.5 meter per second. Now just take some of the target material. Suppose we have to perform a operation on the austenitic steel, which belongs to the family of steel. Okay, so steel materials, I would say. So for instance, if the austenitic steel of 302 SS steel, it does have the machinability index. How we will define its machinability index? If the given a target or the target material having the cutting speed of 0.23, then dividing that with the reference material that we have used it as AISI 112. Okay, if it takes 0.23 minutes per second, and if we divide it by the reference material's velocity or the cutting speed, to be more precisely to describe as the cutting speed, then what do we get as the machinability index? Simply divide 0.23 by 0.5. It is nothing but equal to 0.46. So the tool life of a 60 minute is reached at 0.23 meter per second. Okay. For instance, again, let's take the another example. If it is belonging to a standard AISI 1045 steel, then how do we define its machinability index? If the kitting speed of the target material is found to be 0.36, then by dividing it by the reference material speed, which was AISI 112 by zero point 0.5, what do we get? 0.72. So the tool life of a 60 minute is reached at 0.36 meter per second. What does this tool life means? For the means, if at all we work at a speed of 0.36 meter per second, then we can work with the same tool for a period of 60 minutes. Right? If we work at this speed on the particular material, that is AISI 1045 steel, if you work on this material at a speed of 0.36 meter per second, then we can achieve its machinability index, or we can achieve the tool life for 60 minutes if we do the operations at 0.36 meter per second speed of that given material, right? अगर हम 0.36 मीटर पर सेकेंड के स्पीड मेंटेन करके किसी वो गिवन मटेरियल पे काम करते हैं, तो हमें टूल लाइफ कितना मिलेगा? 60 मिनट्स का, राइट? 60 मिनट्स के बाद वो टूल वियर आउट हो सकता है, डिटोरिएट हो सकता है, और इफ एट ऑल हैविंग अ गुड क्वालिटी देन इट कैन वर्क अ फ्यू मोर मिनट्स. सो वी कैन नॉट से प्रिसाइसली दैट 60 मिनट्स तक ही ये टूल चलेगा. We can often say that it can go beyond 60 minutes, but again, it is different for the different machining process that we have to keep in mind. So we can rate these steels in the descending order of machinability. Of course, since the machinability index for AISI is 0.5 meter per second, then below that, if we get the machinability index of we can say 1045 steel as a 0.72, and below that if we get the authentic steel 302 SS steel, the machinability index to be 0.46. So nothing but it describes that we can rate them in the descending order of their machinability index. So what we have to note, that we have to take a note that the tool life cannot be considered as the only criteria for judging the machinability, as it is dependent on many factors other than the cutting velocity. I have already told in the prior example or in the prior slide that what we have to take into consideration, that this system may be misleading. The tool life may go beyond that 60 minutes. It might be 65 minutes, it might be 66 minutes. It does not only depend on the cutting's velocity. Keeping all such factors and limitations in view, machinability can be tentatively defined as the ability of being machined. Very simply, what is the new definition? That ability of being machined. And more reasonably, we can say that it is ease of machining. हम कितना easily उस पे machining operations perform कर सकते हैं. That is nothing but the machinability of that particular material. So it is not mandatory that it shall depend on the cutting velocity always. It is basically dependent on different machining process that are being carried out. Okay, so what are the different machinability factors that we have to keep in mind? Machinability factors कैसे होते हैं, वो कैसे कैसे अफेक्ट कर सकते हैं, उस पर किस चीज़ों से वो अफेक्ट होता है? The machinability is affected by the following variable aspects, that is work material aspects, cutting tool aspects, process parameter aspects, machining environment aspects. So अभी ये डिफरेंट 4 जो एस्पेक्ट्स है वो क्या है, वो हम नेक्स्ट स्लाइड से देखते हैं. नाउ फर्स्ट वन वाज द मटेरियल वर्क मटेरियल एस्पेक्ट्स. सो फॉलोइंग वर्क मटेरियल एस्पेक्ट्स गवर्न द machinability. ठीक है, जो मटेरियल के एस्पेक्ट्स है डिफरेंट, वो किस तरह से, वो उसके बारे में हम अभी जानकारी लेते हैं. फर्स्ट थिंग इज द नेचर, आइदर इट इज ब्रिटल और डक्टाइल. मटेरियल का नेचर कैसा है? वो बहुत ज़्यादा ब्रिटल है, बहुत ज़्यादा हार्डनेस होने पर भी हमें ब्रिटलनेस आ जाता है उस मटेरियल में. इफ़ इट एट ऑल इन द मटेरियल साइंस और इन द मेटलर्जी वी माइट हैव सीन दैट इफ वी increase the amount of the carbon percentage, then that particular material has a good amount of hardness. But too much of something is always not good. right? If we at all keep on increasing the hardness, it tends to the brittleness of that particular material. Strength increase नहीं होता है, उसकी वजह से brittleness उस material में आ जाता है. तो light operations भी उस material पे we cannot conduct. सो मॉडरेट होना चाहिए, ऑप्टिमम होना चाहिए जो भी उस मटेरियल का प्रॉपर्टी है. सो वेरी फर्स्ट थिंग उन्होंने कहा है कि नेचर ब्रिटल हो सकता है या फिर डक्टाइल. ठीक है. सेकेंड थिंग है माइक्रोस्ट्रक्चर. माइक्रोस्ट्रक्चर जब हम उसे माइक्रोस्कोपिक ऑब्जर्वेशंस में हम उसे देखते हैं तो वो माइक्रोस्ट्रक्चर कैसा है. इट इज़ आइदर इट इज़ अ कोर्स स्ट्रक्चर, बड़े बड़े मॉडरेट शेप्स में उसके कोर्स मटेरियल का जो साइज है, जो माइक्रोस्ट्रक्चर है वो कोर्स है, या फिर वेरी फाइन है, वेरी फाइन, ओके, वेरी माइन्यूट, ओके. इट कैनॉट बी फॉर द डिवाइडेड. Coarse thing it can be divided, but fine thing it cannot be divided again. So the mechanical and the next factor is regarding the mechanical strength, fracture और yield. उसका मैकेनिकल स्ट्रेंथ कितना, यील्ड स्ट्रेस वो कितना सस्टेन कर सकता है, ये सब मटेरियल साइंस की चीज़ें हैं. और या फिर जब हम मेटलर्जी पढ़ते हैं तो उस सब्जेक्ट में हमें ये पाया जाता है कि फ्रैक्चर पॉइंट कहाँ तक हमें अचीव हो सकता है. तो यानी उसका यील्ड स्ट्रेंथ कितना है, कितना स्ट्रेस वो उस पर बेयर कर सकता है, राइट. सो हार्डनेस, हॉट स्ट्रेंथ एंड हॉट हार्डनेस. वर्क हार्डनेबिलिटी, हम उसको हार्डन कितना कर सकते हैं, वर्क हार्डनेबिलिटी. थर्मल कंडक्टिविटी उसका कैसा है, हीट या फिर जो सडन फैक्टर्स है जो कि रिलेटेड टू हीट है वो उसका कंडक्टिविटी पावर कितना है, थर्मल कंडक्टिविटी कितना है. फिर केमिकल रिएक्टिविटी, अगर कोई केमिकल स्पिल होता है तो हाउ डज इट रिएक्ट, डज इट गो डायरेक्टली टू द रस्टिंग प्रोसेस और does it bear that chemical shocks, or we can say the chemical spillings or the chemical effectiveness on that particular surface. Last thing is nothing but the stickiness or the self lubricity. Okay, उसका self lubricity property कितना है, that is nothing but the last point. जब हमें the next point था हमें work material aspects, nature brittle या फिर ductile, उसे कैसे कहा जा सकता है कि ब्रिटल मटेरियल्स आर वेरी इजी टू मशीन एज अ चीप सेपरेशन इज ड्यू टू द ब्रिटल फ्रैक्चर रिक्वायरिंग लेसर एनर्जी. ठीक है. एक इसका प्लस पॉइंट है कि ब्रिटल अगर मटेरियल रहता है, हार्डनेस ज़्यादा रहता है उस मटेरियल में, तो उस तरह के मटेरियल हमें बहुत ईजिली हम उस पर मशीन प्रोसेस कैरी आउट कर सकते हैं. उसमें लेस एनर्जी लगता है, चिप फॉर्मेशन भी बहुत कम हो जाता है. ठीक है. और फर्दर शॉर्टर चिप्स इट कॉजेस लेस फ्रिक्शनल फोर्स एंड हिटिंग एट द ब्रेक सरफेस. So the ductile materials like the mild steel, for instance, we have taken an example that mild steel, it produces the better surface finish, but if formed may worsen the surface finish. Okay. So also cutting forces increase with the increase in the yield strength of the work material. अगर उसका yield strength ज़्यादा है, यानी उसमें बहुत ज़्यादा strength है, toughness है, then for that particular moment हमें फोर्स भी ज़्यादा लग सकता है, राइट. उस पर अगर वो हार्ड है, या हार्ड इन द सेंस कि ऑप्टिमम लेवल ऑफ हार्डनेस है उसमें, तो इट माइट गेट डिफिकल्ट टू अचीव दैट पर्टिकुलर मशीनिंग प्रोसेस ऑन दैट पर्टिकुलर मटेरियल. ओके. सो इट माइट टेंड टू इंक्रीज द फोर्स, और वी माइट नीड द मोर पावर, मोर फोर्स. Next thing was regarding the microstructure. A course of find the value of shear strength and the hence shear force of given material depends on its microstructure. ठीक है. जो shear force पे एक्टिव वेट होता है तो वो किस पे डिपेंड रहता है, वो उसके ग्रैन्युलर स्ट्रक्चर जो रहता है, ग्रैन्युलर स्मॉल ग्रेन्स से कोई भी एक पर्टिकुलर मटेरियल फॉर्म होता है. तो कोर्स माइक्रोस्ट्रक्चर जो रहता है वो लेसर वैल्यू ऑफ वी कैन से shear strength उसमें बहुत कम लगता है. ठीक है. कोई भी मैंने पहले ही कहा था कि कोर्स मटेरियल है उसको डिवाइड करने में कोई दिक्कत नहीं होती, बट अगर वो मटेरियल का ग्रैन्युलर स्ट्रक्चर फाइन है देन वीट मे लीड टू द डिफिकल्टी टू डिवाइड इट इनटू फर्दर पार्ट्स. डिवाइड इट करना है यानी उसको और फर्दर पार्ट्स में उसको सेग्रीगेट करना है, उसको और रिड्यूस करना है उसके साइज को. इन शॉर्ट दैट उसको मशीन उस पर डिफरेंट ऑपरेशंस अचीव करके उसका फाइनल शेप हमने अचीव करना है. तो दैट माइट बी अ डिफिकल्ट पार्ट. सो बट therefore we have to keep in mind that the shear strength can be desirably reduced by either proper heat treatment like annealing of steel, उसे ज़्यादा गर्म करना है और फिर अचानक से उसमें कोल्डनेस उसे करना है, राइट. एनलिंग एक प्रोसेस है विच कम्स अगेन अंडर दिस स्ट्रक्चर, अंडर द सब्जेक्ट ऑफ मेटलर्जी. or what we have to keep in mind is the controlled addition of materials like sulfur, lead, tellurium, okay, leading to free cutting of the soft ductile metals and alloys. नेक्स्ट पॉइंट जो था वो वर्क मटेरियल एस्पेक्ट्स था, हार्डनेस, हॉट स्ट्रेंथ एंड द हॉट हार्डनेस एंड वर्क हार्डनिंग. हार्डर मटेरियल्स आर ऑब्वियसली मोर डिफिकल्ट टू मशीन, वी हैव सीन. ओके, यील्ड स्ट्रेंथ उसमें अगर ज़्यादा रहता है तो सो फॉर इंक्रीज कटिंग फोर्सेस एंड द टूल डैमेज. ओके, सो यूजुअली विद द इंक्रीज इन द कटिंग वेलोसिटी द कटिंग फोर्सेस डिक्रीजेस. ठीक है, कटिंग वेलोसिटी अगर हमने बढ़ा दिया है then it might lead to the decrease in the cutting forces to some extent, okay, making machining easier through the reduction in the shear strength and also the thickness. नेक्स्ट पॉइंट जो हमने देखा है कि हमें स्टिकीनेस या फिर सेल्फ लुब्रिसिटी एक नेक्स्ट पॉइंट था, जिसमें स्टिकिंग ऑफ द मटेरियल, यानी फॉर इंस्टेंस उन्होंने एग्जांपल दिया है कि प्योर कॉपर रहता है, एल्यूमिनियम रहता है, उसके अलॉयज रहते हैं. ओके, formation of BUE at the tool rake surface also hamper the machinability by increasing the friction. अगर उसमें स्टिकीनेस रहता है तो फ्रिक्शनल फोर्स ज़्यादा लगता है. अगर ज़्यादा फ्रिक्शनल फोर्स लगता है तो ऑब्वियस हमें ज़्यादा फोर्स और ज़्यादा पावर की नेसेसिटी होती है. कटिंग फोर्सेस भी उसमें ज़्यादा लगते हैं और टेम्परेचर और वो सब चीज़ें उसमें अफेक्ट करती है, सरफेस रफनेस. ओके, सो मशीनेबिलिटी ऐसी चीज़ों पे ज़्यादा हमें पावर या फिर फोर्स इंट्रोड्यूस करना पड़ता है, ज़्यादा फोर्स इस्तेमाल करना पड़ता है, फ्रिक्शन ज़्यादा बढ़ जाता है, टेम्परेचर और सरफेस रफनेस. And finally it was regarding the thermal conductivity. Lower the thermal conductivity of the work material aspect affects their machinability by raising the cutting zone temperature and thus reducing the tool life. Okay, so thermal conductivity एक another part है which may lead to the to affecting the machinability of that particular material. जो अभी नेक्स्ट पॉइंट्स है जो कटिंग टूल एस्पेक्ट्स है. कटिंग टूल एस्पेक्ट्स डिफरेंट टाइप्स है. We will see these aspects or different tools in the next lecture, because prior to performing or achieving any final product of a particular material, first we have to understand how the material shall be, what are the machinability index, what are the different aspects that are affecting the or that are responsible for either we have to increase the force or we have to decrease the force, either we are going to need the more power to perform the operation, either we have to increase the velocity of the or the speed of that cutting tool. Okay, so these are the different factors that we have to take into consideration before going to the material or the tool life, how the single point cutting tools are behaving, what are the different factors or the different terminologies that are related to those particular tools. Okay, so we have seen a lots of basic thing, okay, that is all about the machinability and on what factors does it actually depend and what actually the machinability means. Okay, so कोई भी ऑपरेशन परफॉर्म करने से पहले या फिर दिस सब्जेक्ट प्रायर स्टार्टिंग टू दिस सब्जेक्ट वी हैव सीन दैट बेसिकली मशीनेबिलिटी क्या होता है, उस पर प्रोसेसेस कौन सी कैरिड आउट होती है, तो वो प्रोसेसेस कैरिड आउट होने के लिए मटेरियल में कौन सी प्रॉपर्टीज होनी चाहिए. ओके, और या फिर डिफरेंट फैक्टर्स कौन से जैसे वो अफेक्ट करते हैं उस मटेरियल को. these are the further parts, having learning about the different process, learning about the different aspects of the cutting tool, different terminology, different nomenclatures. These are the further things, but prior to start of this subject we have to understand what actually the machinability means, how the machining processes are carried out, what are the factors that are affected by the virtue of the different machining force or the powers, or we can say the surface finish to life, what are those different factors that are responsible for attaining the good machinability capability of that particular material. Okay, so thank you so much guys, this was all about the brief start for the very interesting subject that is related to the mechanical industry, that is nothing but the manufacturing process part 2. Manufacturing process part 2 is the very interesting subject. You will learn lots of different machining process, different tool nomenclatures, and yes, of course, this subject is very much important and interesting for the industrial purpose. Okay, thank you so much for giving your patient time to listen this video, and I hope that it will inculcate the interest in this particular subject, and definitely you guys will enjoy this subject very much. Thank you so much. Thanks again.